Alright, here's another example of multiplication of two fractions. This is a little bit different, but it's the same idea as before. It's this fraction times this function. But remember, we can put anything divided by 1, and that may help us with seeing the cancellation of the factors. So x plus 2, that's a linear function. There's no exponents, no GCF, so that's just going to come down. I'm going to go ahead and do the right-hand side first. It's a little bit easier. If you notice, factors of 9 that get you 3, there aren't any. The only factors of 9 are 1 and 9 and 3 and 3, and none of those get you 3. So that's not factorable. So that's just going to come down the way it is. So the thing we have to now look at is the bottom left. And this is a cubic function. So remember, the formula for a cubic function is this. You need to know this from chapter 5. If you have something that's written like this, which is a difference of 2 cubes, the formula a minus b, then a squared plus ab plus b squared. Now this is just something you have to memorize, but a and b are the thing that's being raised to the third power. So like x to the third minus 27, the 27 is not being raised to the third power, so you have to make it that way. So what raised to the third power gets you 27? That would be 3. So in this case, our a is x and our b is 3. All we're going to do is replace all of those with what we have here. So a minus b is x minus 3. A squared is now x squared. A times b is x times 3, which is 3x. And then plus b squared, well, my b is 3. 3 squared is 9. Again, this is something you've already learned. That's why I went through that quick. But that is our factor of the denominator, which is going to go here. So x minus 3, then x squared plus 3x plus 9. Now you can see that this 3-term statement and this 3-term statement are the same factors. Okay, remember, this is being multiplied, so we can cancel all of these and all of those. And your final answer is the stuff on top, which is the x plus 2, and also the stuff on the bottom, which is the x minus 3, and then the times 1 you could put, but you don't need to. So this is your final answer. Okay. All right, last couple examples of the chapter, of the section. This one's a division. Just kind of a quick recap of what we learned probably back in grade school is if you have two fractions divided together, for instance, if I have 2/3 divided by 2/5, I can rewrite that as multiplication. I can rewrite that as 2/3 times 5/2. You'll notice that the 2's will cancel, and you're left with 5/3. That's stuff that you should know how to do. Okay, so we're going to apply that same concept here. So, first things first, we're going to factor. So, 7x is a one-term statement. It cannot be factored. 2x minus 10, you can take out a greatest common factor. A 2 can come out of both 2 and 10, so take a 2 out. When you take the 2 out, the first term is left with just an x. 10 divided by the 2 you took out is now a 5. And we're going to combine this next step with our factoring. I'm going to change this division to multiplication. And I'm going to flip my right fraction. So when I factor the top, it's now going to go on the denominator. Just like we did over here. When we changed it to multiplication, we flipped that right fraction. Same thing here. So I'm going to take this top part and factor out the GCF, which is an x. I'm going to put it on the bottom. And if I take an x out, I'm left with x. And then if I take an x away from that, minus 6x, I'm left with a minus 6. And I'm going to do the same thing. I'm going to factor the bottom here. I'm going to put it on top. Factors of 30, that gets you negative 11, or negative 6, and negative 5. So, start canceling. It's just now, just like the previous examples with multiplication. Now that you have it factored and it's written as a multiplication problem, x minus 5s can cancel, x minus 6s can cancel, and even these x's can cancel. And in this case, what's kind of strange is the only thing you're left with is the 7 over the 2. which doesn't happen very often, but that is your answer. All right, so one more example, just like number 6, just a division problem. We're going to factor. 9x squared is a one-term statement, so it cannot be factored. 6x minus 3, you can take out a 3. You're left with 2x minus 1. And on the top right, remember we're going to change this to multiplication and flip the fraction. You can take out a 3x, and you'll be left with x minus 4. Here you can take out an x, and you'll be left with 2x minus 1. Okay, now we can start canceling. If you notice the 2x minus 1s are the same, they cancel. And let's see here, these x's will cancel. And the last little bit is reducing the remaining parts. So 3 times 3 is 9. 9 divided by 9 cancels. So the only thing you're left with is the x squared on top and the x minus 4 on the bottom. Alright, last example of this section, and then that will be it. Example 7. This one a little bit tougher. It's division. It's got that thing on the side too that's really divided by 1. You just don't see it, so I'm going to go ahead and include that. And it's also got this harder problem to factor here, so I'm going to go do that at the bottom. So if I want to do 6x squared plus x minus 15, I multiply the first and the last. 6 times 15 gets you 90. And we're trying to get factors of 90. That will get us 1. It's actually a negative 90. That's a negative 15. Factors of negative 90, that will get me a positive 1 when you add them together. And those two factors are going to be 10 and negative 9. So I'm going to rewrite the first term and the last term. And all I'm doing is taking those factors of negative 90, which I said were 10 and negative 9. I'm going to use those to rewrite the middle term. So 10x minus 9x. And this, again, this is something you should know how to do from chapter 5, actually chapter 4, and even algebra 1 for that instance. But you're going to group the first two and group the last two and take out GCFs. Between 6 and 10, you can take out a 2. You can take out an x, and you're left with 3x plus 5. You want to have the same thing left inside. We're going to take out a negative 3, and you're left with 3x plus 5. And your factored form is the 3x plus 5 along with the remaining parts, which is the 2x and the minus 3. That's the hard part of this question. That's something we already know how to do. The bottom left, 4x squared, cannot be factored. It's just a single term. I'm going to change this to multiplication, which means that what was on the bottom, which is a 1, is now going to go on top. And then I can take out an x between those two terms, and I'm left with 3x plus 5. And my answer now is going to come down to what cancels. The 3x plus 5 cancels. And that looks to be it. These x's don't. They're on the same level. So what's left over is the 2x minus 3 on top. The 1 is also there, but you don't need it anymore. On the bottom, you got 4x squared times x, which is 4x to the third.